Today we're going to be working on Leetcode question number 313. Super ugly number. A super ugly number is a positive integer whose prime factors are in the array primes. Given an ugly number n and an array of integers primes, return the nth super ugly number. The nth super ugly number is guaranteed to fit in a 32-bit signed integer. So if you have n is equal to 12, what he is saying is like the primes are 2, 7, 13 and 19. The number is going to be 32. Basically, when we're looking at the primes, we're going to start with 1 and then we're going to have this array 2 and then the multiples of it. So 2, 7, 13 and 19 are there, but then the multiples of them are also going to be there. So 2 multiplied by 2 is 4, which is here, and then 2 multiplied by 3, actually sorry, 4 multiplied by so yes, everything multiplied by 2. So 2 multiplied by 2 is going to be 4, which is there. 7 multiplied by 2 is going to be 14, which is there. 13 multiplied by 2, 26, which is going to be there, and so on up to we are only interested in the first n. Then whatever that is going to be like 4, 7, 4, 14, 26 and so on, that is basically 38. That is going to be, and then we're going to be multiply all of those 4 elements by 3. So 4, I'm sorry, and then we're going to multiply that one with the and then we're going to multiply that thing that newly generated array with 2. So 4 multiplied by 2 is going to be 8, which is also going to be there. 14 multiplied by 2 is going to be 28, which is also there. So and then we're going to end up having there's a sequence of first 12 ugly numbers, super ugly numbers. So whose primes are these ones? So and in the end, once we have them sorted, we're gonna just return the index of that, like the once we have created the sorted set of sequence of the super ugly numbers, we can just return the nth element. Okay. For this one, we're going to be using priority queue, and the way our priority queue is going to look like is we are saving basically 3 elements in the form of an array, and we are always comparing the first element of that array. Priority queue. Again, when an object comes into it, the way we compare it as by comparison of the first element, and that's how we are actually inserting it into the queue. Okay, now so we're gonna fill up our queue, right? So for int I equals to 0, I is less than the primes dot length I plus plus. Okay, so we're gonna offer into queue. Okay, so new int, and the values are gonna be that the primes of that I. So this is gonna be 2, 7, 2, 7, 13 and 19, the first element. The second element is basically gonna be the prime, like the prime factor of that. So prime factor of every the first time every prime is also going to be the prime factor of that. Next time when we're adding multiples of that, then it's going to be the same prime factor, but the first entries are going to change, which is basically the initially it's just the prime factor, and then it's going to be the multiple of that, and the third entry is going to be the index of that, like what exactly are we trying to multiply, or how many times we have multiplied the number. So basically a number, uh, like what level are we at? So we are at the 0th level right now. Okay, and we're gonna have another array of nums. You're gonna say that the size of that is just n plus 1, and the nums of 0 we're gonna initialize it to 1. Okay, and we're gonna have an iterator I is equal to starting with 1. So while the I is less than n, so we know that our I is an iterator, and we want to make sure that because we're going to be multiplying I every single time, or actually incrementing I every single time, so that number should be less than the 12. Oh, I mean that number should be less than the given n. Okay, so every single time we're gonna have an entry array, which we're gonna get once we get an array out of this queue. Again, the entry is gonna have three things. The first element is the number, and the second element is the prime factor, and the third element is basically gonna be the index or level. So once we have that, first of all, what we have to do here is basically again multiply the let me just what we are offering back to the queue dot offer is again a new array, and the values of the three elements of that array is gonna be, so the first one is the prime multiplied by the nums of that index plus 1. Again we initialize the nums with n plus 1, and the first is just 1. Okay, and the second one is gonna stay the same, which is the prime, and the third one is always gonna get incremented, like the level or the index is getting incremented. So but we have to do one more thing. We need to make sure that we remove the duplicate. So for that we want to say that if the num, which is the first entry, is not equal to the nums which we created over here uh, at I minus 1. So we want to make sure that if that is not equal, uh, only then we need to increment our I and put the nums of that I equal to num and I plus plus. So again we had to copy the new num to this nums, uh, but we want to make sure that we don't have any duplicates here. Otherwise we are just copying the new num new entry into nums of I and incrementing the I, so that next time we're just putting it into the new one. And I, as I said, this is the index, which we want to make sure that we don't go beyond the given n. So once we are done creating this array up to nth index, we're just gonna return the nums of n minus 1. Dimensions. This isn't the offering of that. Yes. Okay, expected line 8. Forgot to say new. Another typo here. Yes. Looking good. And